Hopefully you had a chance to evaluate some of those things and some of those expressions there and seeing what they are. When you do each of these, you hopefully realize that each of those is equal. They're all equal to what log 24 is equal to. The point isn't that they're all equal. I mean, well, what we're leading to here is looking at, how does this relate to log 24? You have log of 8 plus log of 3. That's equal to log of 24. 24 you could write as 3 times 8. All right? The significance of the 8 and the 3, or the 6 and the 4, or the 12 and the 2 is the fact that those numbers multiply to 24. You learned in grade 9 this exponent rule that said multiplying powers is the same as adding the exponents of those powers. So multiplying numbers, same as adding exponents. Here you're going to learn that multiplying numbers is the same as adding their logarithms. You can add the logarithm of two numbers. It's the equivalent of multiplying them and then taking the logarithm. All right? You can make up your own down below. It says what's log 2 times 3 equal to? It's going to be equal to log of 2 plus whatever log of 3 is. You can test it to make sure if you want. The logarithm of a product, okay? So in other words, logarithm of a product, log of A, B, log of A times B. That's equal to the sum of the individual logarithms, right? Sum of individual logarithms. Log of AB is equal to log A plus log B. That's the first logarithm rule or law that you need to know here. Okay, that property of logarithms, that you can add the individual logarithms and it gives you the logarithm of whatever their product is. Probably then you could actually just predict what the quotient law is without even doing all this. Hopefully you have gone through and had a chance to do it. You should come up with a similar law for this. That one was the sum of the individual logarithms. What's this one end up being? What do you notice? What do you call it when you're subtracting? Because you're subtracting them all here, right? Log of 48 minus log 8, that's got to be equal to log of 6. Okay, they're all equal to log 6. Things that divide to 6. You could put another couple of expressions here. Give me another expression you could put here. Log of 60 minus log of what? Log of 10, right? There's a lot of different things you could put there, obviously, right? Logarithm of a quotient is equivalent to the difference of the logarithms, subtracting, right? So in other words, if you have logarithm of two numbers divided, 1a divided by b, that's equal to log of, which one comes first? Which one do I subtract? What's that? Which one comes first? What am I subtracting from what here? Log a minus log b, right? The one you're dividing by is the one you subtract. The third one here, this power law. Again, hopefully you've had a chance to write out some of those things here. This one's more difficult to see what the relationship is, or maybe not to see what the relationship is, but to be able to write out the law in the end here. If you do logarithms of these numbers, those are all powers of 2. So what we're looking at is how are the logarithms of powers related to each other? Like we want to know, you can do logarithm of 2, log of 4, log of all these powers of 2, log of 8, 2 to the 3rd, log of 2 to the 4th, log of 2 to the 5th, and so on, right? And you figure out what those numbers are. Figure out how they're related to log 2. So what we want to be able to do is not just say, well, look at this is a decimal, it's great. It's, this decimal is this many times more than that decimal. You want to know, how could you get log of 32 from log of 2? How is log of 32 related to log of 2? How can you get it from log of 2? That's what you're looking for here. In other words, if I asked you, like this is log of 2 to the 5th. If I ask you what, see there I go being sloppy again with the numbers, 2 to the 5th, tiny little 5. If I asked you what log of 2 to the 27 is, I want to know how I can get it just from log of 2. That's the goal here. Okay? I got to take log of 2 and do something to it to figure it out. That's what you're looking for as the rule. And then once you've done that, you can write log of a to the power of b. What's another expression that is equivalent to that? Okay, so I'm not quite going to write that out here yet. Give you some time to think about that. See if you can come up with it if you haven't already come up with it. If you have come up with it, you can try working through some of these questions without a calculator, right? Put some logarithms, put those logarithm laws to use. Starting on this one, on number 4, you're going to need the third one, the power rule. So if you're not sure of the power rule, make sure you either ask for help from me or somebody else, or we will talk about it in a minute or two here. I'm going to pause this temporarily. What's the pattern you notice there when you do that? Okay, you get log of when you do log of 2 to the power of 1, you get this number. When you do log of 2 to the power of 2, you get twice that number. When you do log of 2 to the power of 3, you get 3 times that number. I mean, I know you're probably thinking it goes up by this much every time. Every time you multiply by 2, you add that onto the logarithm, right? It follows from the other rules that you have. If you think of it as, whatever power of 2 it is, that's how many times log 2 it is. All right? Every time you multiply by 2 over here, you're adding log 2. That's the multiplication rule that we had, right? It just follows along from that. So that's going to keep going up like that. If you want to know what log of 2 to the 5th is, this is like log of 2 times 2 times 2 times 2 times 2. What does our multiplication rule say that can be? Log of a bunch of things multiplied? I know you just learned it a few minutes ago, but what is the first rule we learned say about that? Same as this, same as log of 2 plus log of 2 plus log of 2. I guess I should have picked a smaller number, but plus log of 2 plus log of 2. There's 5 of them there, right? It's the same as, what would be the short way of writing that? Log 2 plus log 2 plus log 2 plus log 2 plus log 2. What's the short way of writing that? Yeah, whatever log 2 is times 5, right? It's 5 log 2. Because you've multiplied 5 2's together, so it's the same as adding that logarithm 5 times. It's the same as 5 times that logarithm, right? If you go back to that table, log of 2 to the 5th, that's what that is, right? 32 is 2 to the 5th. This is going to be 5 times what log of 2 is. Log of 2 to the 12th, this one down here is going to be 12 times this number. It's 12 times log 2. So if we wanted to write that without doing the rest here, logarithm of 2 to the 12th is going to be, what's that going to be the same as? 12 times log of 2. Whatever log of 2 is, this is a number. This is just a number that the calculator knows, 0.301 whatever. So when I'm saying 12 log 2, I'm saying 12 times 0.301 whatever it is. That's what that is. So the rule that you write for yourself, log of a to the b, what's that going to be the same as? Yeah, let's look at this one and make sure we can get it here, right? Log of 2 to the 12th, where did the 12 go? Oops, where did the g go? Where did the 12 go? In this expression, where did the 12 go? Somebody be brave and say something. Somebody pointed out, I'll highlight it. There it is, right? The way people remember this is they think this. Log of 2 to the 12 equals 12 log 2. They don't just memorize it like that. A lot of people just think, well, this can go from there in front and then get big, right? That's how you can change that. That's how people remember that rule, is they just remember that goes out in front like that. All right. So if you're trying to write a rule for yourself, log of a to the b is b times log of a, whatever that is. Logarithm of a power is whatever that exponent is times the logarithm of the base. I mean, when you try to write it with words, sometimes it can get to the point where it's hard to understand, but the logarithm of the nth power of base b, I used n instead of, if you wanted to match this, I said the nth power of base b, I said b to the n. I mean, whatever numbers you want there, if you want to do this. Log of b to the n is n log b. Nth power of base b is equal to n times the logarithm of b, multiplied by the logarithm of b. Okay, you need to try and apply those rules here. This is where I want you to work through, and I will answer any questions you have. Okay? Hopefully we can be done with this for next time.